All right. So I already posted the last of these videos up online for yesterday, and I'll post this one up as well. I have to do a little editing on my own domain to make sure it goes up there, but again, the link is just dugoutdeal.com, and then I'll post it up on the main domain. Anyways, so by the end of today, not only do I hope that you'll have a better understanding of the curriculum that you're supposed to go through, but that you'll actually be able to build a website for yourself, which I think, personally, is probably the best way to genuinely understand how this works. So that is the intention. Let me quickly pull up the document that I created for this. I'll also share this document that I'm about to go through with you after that. But just like yesterday, I'm recording all this and I'll give you access to it, so I would prefer it if you don't take notes and you just kind of ask questions. Okay, so antecedents to this, just a reminder, brief recall of what we did yesterday is the OSI model, which is our 7-layer model for how the internet operates. 7, 6, 5, 4, 3, 2, 1. And our mnemonic for that is all people seem to need data processing. What's our top layer? And remember? Application. Yep. 10-second description of what the application layer does.
It's like the overall, looking at it, right? It's just like the overall, like the DCS was your example, right?
NSC.
NSC.
That's right. It's actually making the
works.
decision. Yeah, that's right. Yes, that was the analogy in the 13 days example was National Security Council, even though it wasn't quite constituted as it is today. Yes, in our computer example, your application is something like this, a web browser. That is the application that we're dealing with. Okay, all people. What is RP?
Physical.
No, physical's down here. I'll put it in there. Anyways, that's our first layer. Underneath application. So President Kennedy didn't speak Russian, not fluently anyways. He had to write his letters to Nikita Khrushchev in English, and they had to be translated. But being the president, he just sent that down to a lower layer. Somebody else took care of that, made sure that happened, and sent everything along, right? The presentation layer, again, does the same thing. Okay, it does some translation from one type of code to another type of code, from one type of time to another type of time, does a bit of compression, encryption, these kinds of things, right? So that when we send around images like this, we're not sending them around at their full size, their maximum value. We compress them a bit, and the presentation layer sorts it out. All people seem, S, review. Session, that's right. What's our session layer do?
It's like the red phone.
Yeah, okay, the red phone plus, plus some of the other communications channels, binding together Bobby Kennedy's negotiations on the side with the Russian ambassador, plus the red phone syncing all the information together so that we make sure that in the same session we're not getting a little bit of this data and a little bit of that data and it's all higgledy-piggledy all over the place, okay? More natural analogies are things like your Skype call where you're binding the audio channel to the video channel and making sure that they're in sync, okay? Okay, all people seem to, what's our T?
Transport.
There you go. Cool. By the time I spelled it out, excellent. Okay. And what's our transport layer do?
It's the sending of packets, right?
This is one level above packet. We're going to talk a little bit about packets here in a bit, though. So we'll.
It's going back and forth, getting read receipts and stuff.
That's exactly right. That's exactly right. It's technically getting TCP packets, UDP packets, which are not. You can kind of think of them. They're not. Ordinarily, when we talk about packet, we talk about kind of the IP packet, which is our next level down. Okay. All people seem to need. What is N? Network. That's right. Okay. And this
is the packets.
Bam.
Packaging and envelopes.
That's right. That's packing it on our first layer of envelopes. That has a return address, a to address. In this case, those addresses are just IPv4 or IPv6 addresses. It says, I want it to go to this destination. I want it to come back to that destination. We're going to talk about this layer a lot today, because this is kind of the thin waist of the internet. These two together, transport plus the network layer, have kind of really standardized on just a couple of protocols that are really useful for you to understand. If you understand them fully, then, well, you can understand some of the vulnerabilities in the network, and you can understand where some of the issues are. Okay, so that's network. And then what's our, all people seem to need data. This is the data link layer. This is a nice one because the mnemonic actually spells out the first thing. Data link layer. And what does this layer do?
Addresses.
A type of addresses. So our analogy here again for the NSC was we had a certified mail letter. We had Nikita Khrushchev's address on it with the return address of 1600 Pennsylvania Avenue for President Kennedy. Our data link layer, this was kind of the internal post office thing. So the White House mailman takes it, puts it inside a box. He then takes that box to the truck. The truck then drives down to the central post office. Central post office then loads it onto another thing. Well, these smaller links also have their own types of addresses. Each of those little containers in the postal system would have their own type of addresses as well, but they're extraordinarily granular. And you as an individual almost never interact with them, with the exception of the rare times where people ask you for things like your MAC address. That machine address code, that is, what's the name of your bucket? I need to know what specific individual machine I'm going to be talking to. Ordinarily, an IP address is enough to get you where you need to go, but if you need to get really granular, you do this. And these are their own types of envelopes. So just as we take our regular envelopes, and you could, in theory, packet them inside of each other, that envelope, again, goes inside of a bucket. That bucket that the postman is carrying is our data link layer. And our bottom layer is our physical layer. Our analogy here is the postman is actually physically carrying it. In our web analogy, or not our web analogy, in the web context, this is actually an electromagnetic pulse that's being sent over the airwaves or through a line. Like, this is the actual pulse that is being sent here. This is the physical bits of data that are being sent. Okay, so that was a review from yesterday. Now, I would like to take this and apply this to what we're going to do today. All right? And I'll touch briefly on some of these different layers as we go through, but I wanted to rehash them before we did. Now, the first question, looking over some of the curriculum that you all had that I want to ask you, is what is the relationship between this computer right here and this website, console.cloud.google.com? Like, what has actually happened here when I call this up? Maybe the first thing to ask is, generically, these go by a few different names. We can call these desktops, we can call them whatever. But in network speak, for those of you who are doing the training program, what would these endpoints be called? This one and this website. There's multiple names, so there's you can throw multiple names out there, and some of them will be more or less generic. Any ideas?
Is that like an application?
Well, this browser is an application, but this physical machine is what I'm talking about here.
Oh.
We would call a network endpoint, a generic name for a network endpoint is a host. Anything that is connected at the endpoint of a network is a host. Traditionally, often, and more colloquially, you'll generally refer to your host on the server side as opposed to on the client side. Another way to describe this is your client. This is asking for something. This server right here, console.cloud.google.com, this is another computer sitting in a data center somewhere that has sent back this information. I requested that information by typing console.cloud.google.com in there, and it sent it back. Now this server has the ability to have multiple relationships with lots of different clients. Okay, you can have, just as hundreds of people at a time, thousands of people at a time can access NewYorkTimes.com, well, same way for this website. Your machine also has the ability to have multiple relationships at a time, but it's certainly not at the scale that we're talking about here. Like the number of simultaneous connections that your web browser is able to maintain is limited by the strength of this application, is limited by kind of the robustness of a few other things. But it can also have multiple connections at a time, but it's not really designed to be a server, okay? So this layer up here, this application layer, has a parallel on the server side, okay? On the server side, this application layer is going to be, sorry, I just messaged. I won't go into our proprietary stuff here, but we're going to build a machine that has something called the LAMP stack on it. Okay, LAMP stands for Linux, Apache, MySQL, and PHP. Okay, now just like this machine here, who can tell me what the operating system is on this computer?
Windows.
Bam. All right. The parallel to that in the LAMP stack is Linux. Okay, that's our OS. Okay, this is also stuff that's in your networking packet. Okay, Apache. This is your HTTP server. This is the application that is returning things back and forth. All right, it doesn't have a nice, lovely interface like this, like the good people at Mozilla put together, but it responds to hundreds and hundreds of requests from individuals all over the place, and it returns back the information that you asked for. And just as you can be asked for information on your side, like, hey, can you log in on this? Can you provide me a bit more data? You would like to access this website, but what would you like to do? Apache can do the same. All right, you can ask it information like, I want to know what's at this URL right here. Okay, now tell me what is there, and it will reply. Oh well, I looked it up, and this is what came back. Okay, where did it look it up? It looked it up not in this instance, but in the general sense, in something called MySQL. Okay, now here I'm going to stop on a couple of other things that are in the packet of information that I saw you guys go around. You'll note the SQL on the back of here is the same as one of the things that was in your packet that you were trying to go over, which is a SQL injection attack. SQL stands for Structured Query Language. Basically what this means is this is a way to communicate with our databases. Okay? You can ask it things like, okay, I want to know all the contents, select contents from this is semantically correct SQL. You can say, in a relatively understandable English language query, give me the contents of this database where the URI, this little extension at the end, equals home. Okay, and it would return to you, oh, okay, well, I just looked it up, and this is what came back. All right. You also have the ability to write to these databases, right? Every time that you log in to something, you are writing to a database of some type. One of the more common attacks, and this was in your information packet that you'll end up with, is if you're clever about the way that you fill web forms out, you can make it think that the information that you are sending into it is not actually data. So rather than doing something like, well, ordinarily, you could do something like write your name, username, and password to this database and have it return the contents of the web page after you log in. Well, you could do something more clever, like have it disgorge all of the contents of the web page to you if you encapsulate your queries correctly. So rather than in your login field, you put in something like first name and last name, you put in something like quotation marks, select, from this, this database doesn't understand that you're not asking it to do something like perform a normal operation and disgorge its content. So that is the definition of what an SQL injection attack is. It's a bit of a archaic attack. We don't run into them very much anymore because they're so well known, but it does exist, and it is something that the machine that we're about to set up is vulnerable to in its most raw state. Okay, and then the final thing in this LAMP stack is PHP. Now this, actually that needs to be, this is a high-level programming language. Difference here between an operating system and your high-level programming language is your programming language kind of ties everything together. This is what says, all right, well, this request has come in. I want you to open this application. I want you to perform this procedure. But it is, again, especially since we're all native English speakers, relatively understandable to an English speaker. It's just a programming language, okay? So this is the operating system and the server and the database that is going to be operating on top of the virtual machine that we're about to create, okay? So we're going to create the other host that this is going to talk to. Once we create that host, we're going to access the web page content from there. We're going to manipulate it a little bit, and then we're going to go through the domain name system, all right? So that's what we're about to cover. Okay, now, this is not going to be that complicated because at Google we believe we should make things simple. So you can do this in about 2 clicks. All right, so you just go here to Cloud Launcher. I would encourage you guys to do this at home. This is, are you serious? There we are. Look at this reliable machine.
In direct contrast, sir, the NMCI does not believe in doing what it's told initially. Doesn't work like Google does.
Okay, we'll just see if we can do multiple applications. There we go.
Yeah, right. You think it might explain.
Insecure connection, of course. All right, this will be a bad demo if we can't actually select this launcher. Let's run the reverse image. Okay, so all of you, I presume a lot of you have Gmail accounts. If you don't, you can set one up also free. We I think give like $300 worth of credit for the first year or something like that. It's some astronomical amount of money. To set up a machine like I'm about to set up costs about $5 a month to keep it running. And even on our most paltry military salaries, I think you'll be fine if you want to do that. Or you can just create a new Gmail account every month and set up a new one, which is also perfectly legit. Why is this not letting me launch this? Come on. Sorry, guys. You're going to have to press the I believe button on this one. We're going to have to move on. Oh, that's fine. I'm already on it. Alright, sorry. I normally live in Australia, and I'm only about 72 hours out of the Okay, so I clicked on WordPress. Here we go. This is it. It says, should say somewhere on here, that this launches the LAMP stack. Started with PHP, tells you all about these kinds of things. Anyways, whatever. So we hit launch my compute engine. I'm going to select my machine size. And this is about to build a virtual machine, which is set up in Central, and this is fine. We'll have it all run here. Click deploy. And this should be fine. Deploying. Great. Let that build. Oh, there you go on the side. You saw what the lamp stack was. You saw it was building. Okay, now mercifully in the web tech world, lots of things are free, so you don't have to pay for operating systems. You don't have to pay for lots of other things. So, okay, this is currently building this computer. It's installing an operating system. It's adding the application layer, all this kind of stuff. While that's building, I want to ask you a couple more questions. Okay, how do we get to see items on a website? If you want to see a website, what do?
Type in the web address.
Okay, yeah, in broad terms, that's exactly what we do. Now, what, how does that request get to and from that website? I want to cover routing with you guys because it's on your. Right? How does that get from this machine to that website and back? Any ideas? And throw it out. No, the camera's not focused on you. Don't worry. Circle of trust. Any ideas? Stabs in the dark. No? Nothing? Okay, awesome. All right. So, in general, we're going to use that same address analogy that we were using before. All right. When you want to get something from a website, it has to go through a router. That router that you have at your house takes and is the address and label maker. It says, I want it to go to here, and I want it to come back to me. I have an address that it is assigned me, and I would like it to come back. It wraps it in a nice little envelope and sends it out. Now, once it goes from our router, our local one, to the next one, how does it know where to go? Any idea?
Same principle, the networker.
That's true. It is at the network layer. That next router unwraps, brings up that first bucket, says, oh, you're a bucket coming from this guy. Where do you want to go? Oh, you want to go to 192.168.1.1. Okay, awesome. I've got a big list of IP addresses. I've got 19. Where'd my pen go? It's going to have something called a routing table. Okay, it's going to have 6 or 7 of these little what we would call nibbles, these little half bytes of information here in the format 192.168.1.1, and it's going to say, all right, that is assigned to this MAC address, okay? And if it has that in its routing table, then it will just send it directly to that computer. Now, no router in the world is capable of storing the information for every computer in the entire globe. It's impossible. Okay? It would take too long to look it up. This routing table becomes astronomical. So they all have just a few in them, and then if they don't have the address for where it's going, then they hit a default router, which is one level up, and then they ask that, and it says, well, do you know? Well, no, I don't know, but I know how to get you a little bit closer, one step closer, a little bit more generic. Okay, well, let's do that. Okay, then it asks the next one, do you know where to go? No, but I can get you one step closer. I can get you a little tighter on this number. Okay, then it asks the next one, and so on until we finally converge on the appropriate address. Now, what I have just done is substituted IP address in for domain. Okay, you don't often type your IP address in, but we're going to come back to that. Okay, for right now, I'm happy to use this domain, or I'm sorry, this IP address. So let's visit the website that we just created. Okay, this is the IP address of that website. Oh, of course. It's fly. Fantastic. All right. Hasn't been submitted for review yet because we just created it 30 seconds ago. Okay? For all of you guys, you got your phones with you? I want you to open up your web browser and type in this IP address. Anybody who's got a phone. All right? Show us what it looks like. And then I'm going to try and go to...
Yep. 0. 108.
Sorry, I just...
159.
Okay.
That's it.
Okay, thanks, Navy. Go team. All right. Okay, so you see the website? All right, this was the one that we just created a second ago on WordPress. It looks like this. Okay, we just created. It's not amazing, whatever. But this is what's returned when we send out for this information. Now, this is going to kill my demo because I didn't think the Navy was going to actually block at this level. That was amazing. Okay. I'm just going to show you guys this. I can still do trace route on something else. Let me show you this. Of course not. America. All right. All right. We will come back to this, but I can still use the same demo for this. How about this? How about we do ping google.com. All right. All right. Now, let's have a look at what it just did here. I typed in google.com. Of course, clone. I typed in google.com, and it gave me, in return, this IP address. Okay? What is the relationship between domain names and IP addresses?
Like a translation.
Is it a one-for-one translation? How does it work? Anybody want to take a stab? That's fantastic.
Yes. It is.
Anybody care to venture an alternative hypothesis? The one-to-one?
No.
No. All right. Well, the answer is kind of. Okay, which is more complicated than you'd like. In general, it's worthwhile. You can think about it as a one-to-one relationship. It's not too problematic. Okay. If I go into my domain name server here, which I should have dug into a little bit more, and I look at the domains that I own. So I own a little company, a little social enterprise down in Australia that has a non-profit component, a for-profit component and stuff. And they each have different websites associated with them. Okay? If I go here and I look into my domains, you'll be able to see that I can go to the domain name server, in this case GoDaddy, and I can set the speed at which this moves. It's just amazing to me. Look at this.
This is saving lives, sir.
You're kidding. You're just killing me. There we go. All right, America, we finally got it. All right, so down here, this is, sorry, I'll scroll up just a little bit more. This is the relationship between IP addresses and domains. Okay? Inside of a domain name server, you are going to set it to say, all right, I'm going to feed in this, and you're going to pop out this. There's actually a second request that happens. Occasionally your browser will cache the IP addresses that it needs, so it already knows the appropriate address label to put on it. But you can't address something with a domain name. That doesn't work. That will not work through our routing system. It has to be addressed like this. So before you even send a request out to the internet, you need to figure out how this maps to this. Ordinarily, most people don't waste their money by having multiple domain names mapped to the same or different IP addresses. There can be instances where it becomes useful. In some instances, so I'll give you one example right now. In my case, I'm still in the midst of setting up this nonprofit. So in my case, it makes sense for me to forward one domain to another. Okay, so when I type in pgpurpose.org, it will auto-forward me to another domain. That other domain will then be looked up, and I will have yet another. There we go, forwarding. You just saw it there. Forwarded. This is where the value was before, where I had an IP address. And down here, you'll see where it's forwarding to. So in this case, you can see that you can have a one-to-many relationship where you have multiple domains forwarding to the same IP address. You can also do it in the opposite direction. You can have multiple IP addresses associated with the same domain. That direction is actually much more common. The reason is, and this is an important bit for you guys, because we have a bit of scarcity in our IP addresses. Before I move on to that, let's touch on this routing thing a little bit more. Sorry the demo is killing me a little bit because I can't do trace route here because I haven't blocked anything useful. Let me see this real quick. Look at that. That's nice. Okay. Let's talk through this real quick. Now, if I want to figure out how my request is actually getting through the internet, this is one of the ways that I can see it. What I'm doing here is I'm sending a little packet of information with something called the TTL field, the time to live field, with increasingly larger increments in it along this path. And I'm saying I want to get to this IP address, which is google.com 172.217.8.4. Really, really amazing website, our IP address. But I'm saying I want to know how to get there, and I want to know all the IP addresses of all the places along the way that it went. Okay, so if we let's see, we're starting to hit backbone here, which is why it's request timing out. It's not honoring our request. That's okay. If we look up one of those, we can actually determine a physical location for some of these. So let's try this with one of them. And we can figure out just where our mail is going to. Building. You know, they, well, I'm not going to say. Okay, 1, 7. So, important bit is here. I'm sure some of you have looked up something like, hey, what is my IP address before? And it tells you what the location is. Each of these are little hops along the way, little readdressing stations that you can look up where your request gets sent through. And now, this is ephemeral, meaning if we try this again later, we might get a completely different series. And this is where kind of the real genius bit of the internet comes from. Not just the internet, but CyberNet as well as JWix. It all uses this same principle. If you can't find this IP address on a network that you own, then it will send it to the next parent network. Okay? And then it will send it to the next one, and the next one, and the next one, and the next one. What does that do for us? Well, that means that basically you can drop a packet of data anywhere inside the network, and it will get to wherever you want it to go. It will find its own unique path there. And if a portion of that network is killed, it will find a way around it to its destination. And that is a little bit of magic. Like, there's not a lot of magic in the world. I think this is probably as close to it as we can get, especially from a military perspective, because if you imagine that one of these routers gets conked out, after a little bit of time for it to reset and realize that it doesn't have anything reconnected to it, the network will self-heal and figure out a way for your packets to get somewhere, right? And you can, without any cost to you as an individual, use a network that will start from any place in Afghanistan or Iraq or any other place where you guys have been, return data from a fixed point to you in an unknown point, or vice versa. You can take that another unknown point, move that somewhere else in the network, reattach it, have it sync up, and then say, hey, I want to access that in a different location when when another host reconnects from a network in another place. And that, as I said, is, I think, personally, just a little bit of magic. Important bit for us from a DoD perspective is that gives us a bit of redundancy and a bit of ability to survive any point attacks on the network, right? And that's the most useful bit of this packet switching idea. All right, let's cover that. OSI model. Trace route. Okay, when you're at home and you're not stuck in the Navy network, we'll try this a little bit more and find the different hops on it. All right, now